All right, today is 15.4, graphing exponential functions. Okay, graphing, we're going to start with graphing increasing positive exponential functions, and we're going to go, this is a long video, so there's 4 of these we got to do. All right, the symbol infinity represents infinity. We all know what that is. We can describe the end behavior of a function by describing what happens to the function values as x approaches positive infinity and as x approaches negative infinity. Okay, and this is what that means. So go ahead and write that. Okay. And that symbol in the parentheses really does mean as x approaches infinity, and that other one is as x approaches negative infinity. And we'll be using that quite liberally through this lesson. All right. So graph each exponential function. After graphing, identify a and b, the y-intercept, and the end behavior of the graph. Okay. So f of x equals 2 to the power of x. Choose several values of x and generate ordered pairs. Really, what you need to do is you need to just use those 4 numbers right there. -1, 0, 1, and 2. You may need to use -2 sometimes, but not really, because you're going to be able to tell. All right? Thank goodness they worked it out for you. Then they wanted us to graph this ordered pair here. So we go ahead and graph it, and you can see that it's a nice smooth curve, and there's the points. They give you a. Now, whatever, and that's just here, right? When x equals 0, it's what's left. Okay? So when x equals 0, that is your a. Okay, and you can see here it's the same here. All right, our b is 2 because what they're using is they're using the last 15.3, right? We did that f of x equals a times b to the power of x. Okay, and that's what they're pulling off of. That's where that a and b is coming from. Okay, so here's that end behavior stuff. All right, end behavior as x values approach positive infinity, y values approach positive infinity, and that's where it's going here. You can see that right here. It's at y is going off to infinity as x goes off to infinity. The bigger x you put in, the bigger y is. As x values approach negative infinity, okay, y values approach 0. They never get to a negative number because it gets closer and closer to the 0, but it never technically touches it, okay? You can put in any negative number for x. The bigger the better, and you'll see that unless you round, it never gets to 0, okay? And this is how you'll be writing this from here on out, okay? After you don't just write this. No. You need to write all of this, okay? Don't write all of this, okay, the first time. After that, you don't need to do that. But you just need to note, you need somewhere in your notes that this says this, so that whenever you write this from now on, okay, you'll be just doing this. You just need to know what it means, okay? All right. Here's this one, all right? So f of x equals 3 times 4 to the power of x. There's the numbers that we're going to use. I'm going to pause the video, and I'm going to generate those numbers for you. I'll work them out, and okay, so there's -1, 0, 1, and 2 worked out for you, okay? Go ahead and write those in, and I'm going to come down here. I'm going to graph these, and then I'll come right back, and we'll go ahead and answer all these questions. All right, so there we go. I've gone ahead and plotted those points. I'm going to move this out of the way to show you where the points are plotted, okay, so you can see that. I know my line's not very straight. I apologize about that, but I did my best. Okay, so I graphed the ordered pairs. Now, here, remember, we're working off this general idea. When they're talking about this a and b here, you might want to put off to the side that this is what they're talking about, okay? So my a is given to me. It's right here. It's 3. It's also my y-intercept. Okay, so you could just pull that relationship right out. You can understand it, and then you can obviously anything to the power of x is our b. So our b is 4. All right, and then our end behaviors as x approaches infinity, y shoots off into outer space. Okay, which means it's approaching infinity also. And then as x approaches negative infinity, you can see that y is approaching 0. Okay, it's getting closer and closer, and it's never touching it. Okay, all right, so let's move on. Okay, here's your turn. Remember on on your board here, the whiteboards, you have the graphing ability, so please use that. Okay, graphing decreasing negative exponential functions. Okay, again, you can use end behaviors to discuss the behavior of the graph. All right, it says graph each exponential function. After graphing, identify a and b, the y-intercept, and the end of behavior of the graph. Use end behavior to discuss the behavior of the graph. All right. So here we go. We got this f of x equals 2 times 3 to the power of x. They've chosen several nice little numbers there for me to work with. Okay, they changed these decimals. If it was up to me, I wouldn't change it to a decimal. I think that's bad of them. So really this should be what? Negative 2/3. Okay, I wouldn't use this. Okay, use fractions. They're more exact. And you can even like graph them a little bit easier. Okay, so there we go. That's our end behavior, what it looks like in end behavior. Okay, I mean, what those look like as they're graphed. Sorry about that, I lost my mind. Okay, and here we go. They graph the ordered pairs for us. Our f of x is equal to negative 2 times 3 to the power of x. So our a is given. Remember, again, I'm going to write this. This is the last time I'm going to write this. They're talking about this f of x equals a times b to the x. Okay, so there it is. So it's given our a, it's given our b, and our y-intercept is our 0, comma a, if you just want to start looking at it like that. Okay, as x approaches infinity, y goes to negative infinity, and you can see that right here. Okay, and as x goes off to negative infinity, y approaches 0, and that's right here, even though it kind of blends in right there. And while it looks like it touches the x-axis, it never, ever, 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 ever touches the x-axis. All right. All right, again, I'm going to pause the video here. I'm going to fill this out for you, and it'll be like magic. Poof, and it's there. See how much magical that is? All right. So there, I go ahead and work those numbers out. I'm going to come down here and graph these numbers real quick, and when I come back. All right. And like magic, it's done. All right. Here we go. So they're talking about a. Again, our a is given, or if you're not sure what the a is, whatever you put in x for 0, it's whatever is what your a is. All right. So there's our a. Our b is what is being put to the power, and 4 is being put to the power. All right. And now here the end behavior has kind of changed just a little bit. So as x approaches infinity, y goes off to negative infinity. Okay, it goes farther and farther. It gets a bigger and bigger negative number. All right, and then as x approaches negative infinity, y gets closer and closer to 0. Okay, just gotta remember this. Okay, it's very easy to do this. All right. Okay, so it's your turn. All right, graph the exponential function f of x equals negative 3 times 3 to the power of 3. All right, and here's the last but not least. Okay, graph each exponential function. After graphing, identify a and b, the y-intercept, and the end behavior of the graph. All right, I'm going to immediately change this into a fraction. I don't like this. Okay, so this is going to actually equal 1/2 x. Okay. All right, so they've worked it out for us. Okay, again, I'm going to change these to fractions because I don't like decimals. Okay, I think decimals are a little bit harder to work with. Although, if you're having a hard time seeing what a quarter is, I guess it's okay to work as a fraction. I mean, as a decimal. All right, and here again, they've given us f of x is equal to 5/10 to the power of x, or 1/2 to the power of x. And our a is 1. Okay, our b is 1/2 or 5/10. And our y-intercept is 0, 1. And you can see our end behavior as x approaches infinity, y gets closer and closer to 0. And that's right here, okay? And then as x goes to negative infinity, y gets closer and closer to infinity, I should say. It doesn't get closer and closer, but, you know, shoots off into outer space, as I like to call it. All right? Here's this one. I'm going to pause this, and I'll be right back. Okay, so I've gone ahead and worked these out for you, and as you can see, I'm going to go ahead and graph them. But as you can see, as x goes to infinity, y is going to get closer and closer to 0, and as x goes negative infinity, y is going to go off to 0. Off to infinity, all right? So I'm going to go ahead and graph that and prove that to you right here. All right, I'll be right back. All right, so there's my graph. I'll show you that I plotted it, I graphed it. All right, there it is. Okay, so our a is 2, our b is 2/5, or when we get all technical with it, okay, and our y-intercept is 0, a, okay, it's always that. All right, our end behavior as x approaches infinity, y gets closer and closer to 0, okay, you can see that right there. And as x goes to negative infinity, y goes off into outer space, which is called another name for infinity, okay? So that's how that's going to work, all right? All right, you got one to do here, okay, and then our last one, which is a graphing increasing negative exponential functions, all right? All right, and they've gone ahead and worked these out for me, all right? Okay, we've seen this before, it's just in a negative aspect. Okay, and here they graphed it for us, okay, and they a equals -1, b equals 1/2. Again, I don't like decimals as much as I like fractions. Y-intercept is 0, comma a, or 0, comma -1. In behavior, as x approaches infinity, y gets closer and goes to 0. And you can see that right here. And then as x goes to -infinity, y gets closer and closer to -infinity. Okay? All right, so that's not too bad. All right, so we're going to do this one right here, and I'll be right back. Okay, so here's those values worked out. I'm going to go ahead and go below and graph those. Okay, I've started to fill things in for us because that should become pretty automatic now. All right, the only thing I really want to talk about is end behavior. So as x approaches infinity, you can see y is getting closer and closer to 0. And as x approaches -infinity, y shoots off into outer space, but in a negative aspect, right? So that's -infinity, okay? All right, here's the last one that you got to do. Okay, I know there's a lot of work on this one, so I don't know if you'll get done in time. Hopefully you will. Okay, because I'd like to see this completed. All right, and when you get done, I want you to do HRW 1 through 21 odds only. Show all your work that is to be turned in. All right, if the graphing becomes too hard, just let me know, and we'll work this out a different way.